Have you ever seen an old map and thought, how did they know that coastline before the instruments even existed? Tonight, we separate legend from evidence, hidden coordinates, lost charts, and the real methods that turn sky and sea into maps. Thesis: this is not about proving a vanished super civilization. It's about something more grounded and more impressive. Humans across centuries built accurate geography, piece by piece. They used the sun, the stars, compasses, distances, and repetition. Some sources survived, many did not. The hidden part? Often just missing links in a long chain of measurement. Chapter 1. Latitude was the ancient superpower. Fact: latitude is measurable without modern tech. Method 1. Measure the sun's height at local noon. Correct for the sun's declination on that date. Result: your latitude. Method 2. Measure the altitude of a known star when it crosses the meridian at night. Again, adjust for declination. Method 3. Estimate by the pole star's height above the horizon. Not perfect in antiquity, but useful. Bottom line, people could fix north-south positions with surprising accuracy. When later cartographers placed those points on a grid, the result can look mysteriously modern. But the method is clear: sky-based latitude plus careful logging. Chapter 2. Longitude was the hard problem. Longitude demands time. To know your east-west position, you need to compare local time to a reference time. Before accurate clocks at sea, people tried. Lunar eclipses and other rare celestial events to sync time across distances. Lunar distance method, workable later with superb tables. Or dead reckoning, speed times time plus compass bearing. Useful, but drift accumulates. This is why early maps often squeeze or stretch the world east-west. If a chart seems too good in longitude, check for local anchoring. One known point can make a region look precise, while the rest quietly warps. Chapter 3. Portolan charts. Accuracy without the math. In the 1200s to 1400s, Mediterranean Portolan charts nailed coastlines. How? Not by theory first, but by practice. Sailors recorded bearings with the magnetic compass. They estimated distances by experience. Workshop compilers reconciled many voyages into one coastline. The outcome: charts that worked at sea, even if they lacked a formal global projection. This is not mystical. It's an early data pipeline. Chapter 4. Fra Mauro and the Indian Ocean Memory. Around the mid-1400s, a Venetian map known as the Fra Mauro map integrated a flood of reports from traders and sailors. It suggested the Southern Ocean was navigable. It positioned East African and Indian coasts with a realism that surprises modern viewers. Why? Because the Indian Ocean was a data highway. Monsoons set sailing seasons. Repeated routes produced repeatable notes, bearings, days, landmarks. When these were compiled, the geography looked ahead of its time. But it was the time, just not the textbooks many people read. Chapter 5. The Cantino Planisphere. State Secrets on Vellum. By 1502, an Italian-born copy of a Portuguese world chart leaked out. The Cantino Planisphere. It depicted Atlantic coasts, including Brazil and Caribbean shapes, with confidence. This was not magic. Centralized, crown-controlled cartography collected voyage logs, then guarded them. Many maps didn't vanish by conspiracy. They were secret, then lost to war, water, and time. Chapter 6. Piri Reis, the most misunderstood map. In 1513, an Ottoman admiral compiled a world map. He wrote in the margins that he used many sources. Iberian charts, a chart attributed to Columbus. That single note is the key. It was a compilation, a collage of data. Claims that his southern shapes are precise, ice-free Antarctica do not fit the evidence. Scale is off. Latitude markers are uncertain. The form matches period fantasies of a great southern land. What the map really proves: networks of charts existed that we no longer have in full. Chapter 7. What erasure really looks like. Most map losses are boring. Vellum decays. Workshops close. Libraries burn. States lock up strategic charts. Scribes copy, and errors creep in. New, better charts replace older ones. Over centuries, only winners remain. But sometimes a leak, a copy, or a monk's obsession preserves a slice. Those slices carry hidden coordinates, forward pieces of older measurements, embedded in later art. Chapter 8. How to read hidden coordinates like a pro. Separate latitude from longitude when judging accuracy. Latitude is often strong, longitude is often weak. Watch for projection effects. A coastline can look modern or wrong, depending on how it's laid over the sphere. Look for regional anchoring. One well-known cape can stabilize a whole segment. Ask what data type fed the map: bearings and days at sea, or sky-based coordinates? Closing hidden maps are not proof of magic. They are proof of memory. 1,000 navigations, 10,000 measurements, 1,000,000 careful eyes. When the myths fade, the real story shines brighter. Humanity learned the world by tracing it again and again until the lines agreed. Call to action. If you want a companion PDF with case studies and projection demos, say Maps PDF in the comments. I'll build a viewer guide you can use to evaluate any old map like a historian. A coastline appears on a centuries-old chart. It's in the right place. It looks modern. So where did those coordinates come from? Tonight, the lost grid beneath the legends, and the real techniques anyone can test. We're not hunting a vanished world empire. We're following evidence that survived. Sky geometry for latitude. Bearings and distances for coasts. Compilations that stitched fragments into charts. And the messy human reasons so many originals disappeared. Chapter 1. Sky to ground, building a latitude backbone. Imagine a simple instrument and a clear sky. At local noon, measure the sun's altitude. Subtract the sun's declination for that date. The remainder is your latitude. At night, measure a bright star at meridian transit. Adjust for declination, or use the pole star's height as an estimate. With tables and patience, ancient and medieval observers could nail latitude within useful margins. They didn't need a satellite. They needed repetition. Chapter 2. Why East-West fooled everyone. Without precise timekeepers at sea, longitude was guesswork plus clever hacks. Sailors used dead reckoning, speed times time, corrected by compass. They used rare astronomical coincidences, eclipses, occultations. Even later, the lunar distance method demanded elite tables and skill. So when you see a very right-looking east-west spacing on an old map, pause. Is it anchored by a known reference? Is the rest stretched or squeezed? Maps can look globally great because they're locally pinned. Chapter 3. The Portolan Paradox. Portolan charts mapped Mediterranean coasts with uncanny fidelity. But they were built from pilots' practice, not academic theory. Bearings from compasses, distances from experience. Copy, compare, correct. Copy, compare, correct. The paradox, mathematically simple, practically superb. Their legacy. Proof that data aggregation beats pure speculation. Chapter 4. The Indian Ocean's Living Archive. For centuries, monsoon winds set a sailing calendar from East Africa to India and beyond. Navigators tracked bearings, landmarks, stars, and days. Guides and rudders encoded this, a practical, portable database. When mapmakers finally compiled it, the result shocked armchair Europe. Believable coastlines, credible distances, not because of secret satellites, because of thousands of round trips. Chapter 5. State secrets, smuggled lines, early 1500s. The Atlantic opens. Voyages multiply. Courts collect charts and guard them. Sometimes a copy leaks. The Cantino planisphere is a famous case. Look closely. Wind roses, rum lines, treaty meridians, confident coasts. It's the moment when paper became a strategic weapon. What got erased was often classified, then lost. Chapter 6. Reading the Piri Reis fragment without the hype. An admiral compiles a world. He cites many sources, including Iberian charts. He sketches familiar Atlantic coasts and a speculative southern mass. Later, people point and whisper, Antarctica. But careful checks say otherwise. Latitude mismatches. Shapes drift. The southern land reflects a common Renaissance idea, Terra Australis. The real treasure is the note in the margin. A network of charts once existed. We have a shard. The rest mostly gone. Chapter 7. Projection magic. How the same data looks different. Take a curved Earth. Flatten it to a page. Choose a projection. Now watch a coastline stretch, compress, or rotate. If a modern viewer compares apples to oranges, one old projection to a modern one, mystery appears where math alone explains the shape. Pro tip, always ask, what projection is this? And what was the anchor? Chapter 8. Hidden coordinates define the boring way. Here's a sober definition. A hidden coordinate is any accurate geographic relation preserved in a later map, whose original logs are taped. Examples: a cape plotted at the right latitude, a baked curve that matches modern coastline within pilotage error, a chain of ports spaced plausibly by sailing days. These are fingerprints of missing documents, not proof of time travelers. Chapter 9. How maps really vanish. Vellum rots. Ink fades. Libraries burn. Workshops stop recopying older sheets when new standards arrive. States lock archives, then wars scatter them. Languages block access for centuries until someone translates the old pilot books. Call it erasure if you like. Most of it is entropy. Separate latitude judgment from longitude judgment. Check for regional anchors. a known cape, a famous port, a star measurement. Look for Portolan logic. Rum lines and dense toponyms equal lived experience. Respect projection. Shape error is not always data error. Reward cumulative evidence. Distrust single wow features. Yes, there are hidden coordinates in old maps, but they're not magic coordinates. They're human ones earned by sunburns, star charts, wet log books, and careful hands. If anything was erased, it was the names of the workers, sailors, scribes, chart makers. They gave us the world, one bearing at a time. Comment, bring the sources. If you want an on-screen pack, artifact names, dates, and projection overlays you can pause, study, and reuse in your own projects.